So I just wanted to start by explaining Neo4j, which you can't do that without explaining what graphs are. So most of you seem to be pretty experienced, so this hopefully won't take too long. I'll just sort of gloss over it so we all get up to speed. But so yeah, graphs. This is usually what people think of when you say graphs. You get sort of this Excel and sort of making charts and stuff. But that's not the graphs we're talking about. Graphs is all about the data that you get and connecting it. And so usually you have some chunks of data or some snippets of things, and they're all often connected in different ways. So by looking at these, by recognizing that there are things relating these snippets of data, you get the graph. So that's basically all the graph is connected data. So you can have anything can be connected to anything else. It's all sort of hand wavy what actually connected data means. And I stole some of these slides from the marketing department, so I might not be an expert on all of it. Exactly. So this is an example of some data you might have if you're a hotel. So you are a hotel. There's rooms in the hotel, and they're connected because the hotel has rooms. The rooms are apparently part of the hotel. And you have availability. That's also data about the rooms that is then about the hotel. And these can be modeled in this way. Of course, the popular one is about social networks, about people and who you know, and sort of doing friend of a friend queries and finding out interesting social networks. And you can extend that with other things about the people, where they work and how they can relate to other people and where they studied. And you can sort of get nice big graphs from all this stuff to see how you're connected to people sort of in a big network. So this is basically sort of something like LinkedIn. You might see there where you get recommendations for friends you might want to follow because, hey, you studied at this school and you have this other friend that you work with and he studied at school. You're connected in some way in a small graph. And these graphs become part of big data. This is the part about the marketing material, these nice big transitions that I haven't practiced. So yeah, these big graphs contain all these smaller graphs that you might be interested in querying about and finding local information, which if you can imagine that this huge chunk of data could be really hard to manage, especially if you have to sort of model it in a traditional relational database. So this is all about how you represent your data when it comes to representing it on disk. So there's basically two ways to do it, sort of the way we all know. You take your data and you line it up all nicely in these columns, and then put it in your SQL database of choice. And that definitely is not a bad thing to do for some cases because it's what we've been doing. And this is really good if you have data that's sort of easy to put in these columns. Things that you can fit into an Excel file on one sheet. That stuff is really similar to all the other data at the same type. So it fits really well. Things aren't going to change a lot. Yeah, and especially when the data is just sort of separate. There's no real connections to it. Then you don't really need to worry about anything and life goes on. But you also can have data where the connections are really important and it doesn't really always fit so well in these nice columns, or maybe it does, but then you have to get a different sort of table to put all and these other types of nodes in different columns, and then you have another table for nodes that fall into a different column, and the next thing you know you have this massive sort of, if you do it in Excel, you have this huge Excel with 100 different sheets for all different data, and it's a huge mess. Well, then maybe you're really working sort of against the grain. You don't want to model it that way. And that's when something like a graph database becomes really helpful. So it's really good for these systems where the way to model the data is really difficult to sort of pinpoint, but you can sort of just look at it and see, well, it all fits in a graph just naturally. So why try to put it in a relational database? And another nice feature of the graph is that as you're sort of building these projects in an agile method where your things are changing every day, the graph makes it easier to sort of iterate over and over, because the model might change as you grow, as the project keeps going, or as the business evolves over time, even on the yearly cycle. Yeah, and obviously with graphs you have the relationships. So when the relationships between data is important to you, then it's valuable to store it in a database that also values those relationships. And so trying to speed up a bit, but the graph databases have really, or graphs in general, have really made a lot of changes to how certain businesses work. So of course Alta Vista, which I've heard about in the history books, but I'm kind of young, so I only know about Google. But apparently, by using graphs, it's gotten a lot better for search engines. Nobody uses Monster anymore, but I actually have heard of that one. But no, I never use it. I use LinkedIn because that's really more interesting, because you have connections between people. Yeah. And this one I don't. Yeah, well, I also still use banks, but PayPal is pretty cool too. Yeah, and so Neo4j is the sort of first database that really has taken this idea of storing things as a graph and been built from the ground up to do that really well. So yeah, I'm kind of want to speed up a bit and go through this section. But so we have graph databases and graph projects, of course, apply to a lot of industries really well, and surprising ways. Surprising for me, I always thought graphs were just for social things, but in a lot of these cases, companies are using it to solve really interesting problems in ways that just couldn't be done with a relational database without doing massive work. So, of course, some use cases are real-time recommendations. And, of course, some customers really get a lot of value from that. So Walmart does that as well. MDM, something... Yeah. I don't want to act like I'm trying to sell the database to you too much, because this is basically what these slides were for. But there's a lot of great things you can do with Neo4j that I didn't know about. Master data management is really important. Fraud detection, that's a really interesting one. That's sort of something you can do on the fly with a graph database, that something otherwise you'd have to do sort of in a batch processing system. Graph search, obviously. Networks and IT ops, that works really well in Neo4j to sort of monitor all your systems that might be connected in unusual ways, and figuring out when something goes down, what does that affect? What part of the graph is going to be cut off because of this node somewhere is offline? Yeah, and ACL, that's also really easy to do with Neo4j. So, yeah, this is an awesome way to see that Neo4j really is used by a lot of people. So join the club, be cool. So graphs are great because they're really intuitive, they're easy to use, they can be fast for certain problems that otherwise would be really slow, so join intensive things. And so intuitiveness, that's sort of the whiteboarding principle. You draw it on the whiteboard, and it's easy to model in the graph. Oh, look at that. Neo4j can be really faster, especially when you're doing join-intensive queries. So things that you would have to work really hard to even write the SQL query to get it to join on the different tables for the different data you're trying to use for your query. It can be so much easier to just write it in SQL, in Cypher. And then you don't have to be clever about how you're going to get everything to line up. You don't have to be clever about, oh, I should use this index and make a index on these joins and use it in this way to get everything to line up just right. And then next thing you know, you've done it, but you've got 10 indexes just to get the join to work. And then you've got a monster of a SQL query that you hope works. Yeah, and it's really easy to move fast with it. One of those reasons is because it uses Cypher. So Cypher is our query language you wrote. What? This
reminds me of what I was telling you, but...
Yeah. Yeah. So apparently this is the same query. And as you can see, this one is smaller. So smaller is better. Yeah. So that's been my biggest takeaway making the little project that I'm going to show you soon, is that it's surprisingly easy to get things done with Cypher. It's easy to sort of see what's going on in the query and then thinking about, okay, I want to make a recommendation for this. How can I translate that to Cypher? You can pretty quickly do it, whereas I really can't imagine how you do it in SQL. Also probably because I've never really used SQL.
Could you tell us this great language what that Cypher query actually does? Find some
This query itself.
persons that are...
Yeah, this, okay, so we find that we have a boss that manages subordinates. Subordinates manages someone that reports to them. So if you're starting from boss John Doe, return your subordinates. Oh, maybe this is report. Yeah. So people that report to you, that work for you, and count how many reports they make or how many people report to them. Something like that. Sorry?
In friends of a friend type of
Right. Yeah, it's kind of, I guess it's friends of friends. It's friends of, it's reports of sub. So maybe these are kind of sign of the same as friends of a friend. And this can be not just friend of a, yeah, it is friend of, because I mean, the distance between you and the second level node is can be between up to 3 hops deep.
So it's a unique recursive joins, either these common table expressions in SQL that even people who design them can't express, or explicit very, very deep joins, like in this statement to using SQL. Here you have 0 to 3, that's 3 levels down, everybody.
And what's fascinating about that query is suddenly reports can occur in different columns and different rows. The same sub can be a report in a different row because of the variable length match. That's really impossible, but it's hard.
Right.
And also the query on the left takes minutes to run.
Yeah, probably. So yeah, let's just, so again, Cypher is a language that's used to query in Neo4j. It's a language that we invented and are opening up to the world so that it's now possible to write a Cypher for, well, you can't write Cypher for another database at the moment, but it's available for other databases to implement. And so hopefully will be soon, because we're working with a couple of other vendors to do that. But what is Cypher? So it's easy to model this kind of relationship in Cypher. So you represent nodes within parentheses, and edges or relationships in square brackets, and the direction of the edge with an arrow.
ASCII art graphs.
Yeah, ASCII art. Who would have known ASCII art could have been a query language?
It doesn't say that down left.
Correct. So this is, it's everything, all the edges are directed. in the graph. But the directionality of the edge in the query doesn't necessarily have to be directed. So this implies that Ann loves Dan, but Dan doesn't love Ann. But the node Dan in the database knows that he's loved by Ann. So whether you're doing the query from Ann to Dan or Dan to Ann, it works just as well. You can evaluate the query just as fast. Sort of implementation thing.
In the relevant place is double link. When it's actually the data is written in the database, it's double link, but you know which direction by description.
Yeah, you know which direction it is, and you know which direction it is, but you can still query it in the reverse direction. And you describe properties about nodes in sort of a JSON type syntax, so with curly brackets and property colon and value. Right.
So you have to have a direction
When you create it, yeah. So they have to have the direction.
you could have directly double link direction.
No.
I have to mention twice.
If Ann loves Dan and Dan loves Ann, then you have to have two relationships.
Two lines.
Yeah. Right. So if you wanted to query and find, so the previous syntax was about creating and data in the database. This is a query to find the same relationship or same bit of information back. So you would write your query almost exactly the same way, but you use the match clause at the beginning. But you leave the target of the query sort of blank. So this is a variable that you're assigning to this node. And so the database will evaluate the query and fill in like possible values for this node, and then you want to return that. So in this case, it will tell us that Ann loves Dan. So yeah, Cypher is really popular. People apparently tweet about it, but sorry, didn't see that. So now I want to sort of switch to the practical part of this with some demos. And I see some people still here. It's kind of weird. Okay. The ghost of Dan and Ann. So the project that I was doing for this was based on one that's done by another employee at Neo4j called Rick van Broeken, who was here last month, and he has a really nice presentation and database about beer data, but he's Belgian, so it's only Belgian beers. And so I thought, well, that sounds like a really cool thing to do. I'll make a website about that with, recommending beer. And there's a number. So I'll just talk about sort of how I went and did this. So the first thing that you got to do is get data. So of course you can go to Wikipedia and get Belgian beers like Rick did, but I like more than Belgian beers, and there's a lot more than Belgian beers, although there are very good beers. And there's also a couple of other beer databases that you can try to use. So ratebeer.com is a popular website that you can find beer data. Untapped is an app that you can sort of check in and like and rate beers. And there's another one, BreweryDB, is a database that you can use. So if you're ever planning on making a website about beer, took me a week to research all the beer sort of sources that exist in the world. So of course you don't want to use the Wikipedia one because it's small. RateBeer is a nice site, but they don't have an API anymore, so you can't really use it. Well, you can scrape it, but that's kind of illegal. Untapped is also pretty awesome, and you can get an API key. I actually got one, but not in time to actually use it because it's kind of more complex data that they have. But Untapped is a bit difficult to get access to. So the number one choice is brewerydb.com. This website is awesome because you get tons of beer data, and it comes on a really easy to use API. They're really cool guys, so you should use them. So from the data that I got to do this contains 5,000 breweries and 52,000 beers. And the data about these sort of beers and breweries is more than this, but this is the main stuff. It's the breweries. You get the name and the beers that they make, and the brewers have all this information about the beers. The interesting ones is ABV, which is the alcohol by volume. And IBU is a measure of bitterness of beer. So really dark. Well, IPAs, I guess, have a high bitterness IBU rating. And ales have probably a low bitterness. Is that correct?
More or less, yeah.
And you also get nice pictures of the beers. And you get so much more data, but I didn't look at all that yet. So the first thing in any project, you have to get the data into the database. So there's a number of ways to achieve this with Neo4j. You can load Cypher. You can load CSV files directly as Cypher statements. That's really great if you have existing data that's in some other format, but they have a CSV export function. Then you can do it that way. But then there's also drivers in a couple of different languages. So you can do it you can write a Python script and talk to the server over HTTP, or in the next version over a byte protocol. So a really fast way to talk to the server. There's also Java drivers. There's .NET drivers, JavaScript, Python. Those are the official drivers. There's also some unofficial drivers for a couple of languages like Ruby, C, probably a couple more esoteric languages, maybe. So I found this really nice project because apparently I'm not the first one who wanted to use Java and get data from this website. So this one guy made an API to sort of query the data from this BreweryDB site. And by using that, I made a simple script to, oh, this is going to be hard to see.
Presentation mode. Tools, I think.
Tools.
Maybe not. Oh, maybe view.
Yeah.
It was there. Toggle presentation mode down the bottom. Yeah.
Oh, that's not.
That didn't help at all.
Oh. Heck, yeah, that's.
Okay.
All right, so this is my awesome program where I download beer into Neo4j. So the first thing you have to do is you have to set up your project to depend on Neo4j. And the third way about getting access to the database that I didn't mention is that Neo4j is written entirely in Java. So it runs in the JVM, and then therefore you can run the database inside your Java application if you're using Java. So you can instantiate a graph database object and then talk to it directly, sending it your queries inside the same JVM process. So that's probably going to be the fastest way to write data to the database. If you're doing big imports, it might be worth looking into it that way. Right, so of course you add a dependency in your project in Neo4j, and then you get access to everything. So you simply instantiate the database with this one awesome line, passing in the location that you want to write your database files to. You start a transaction because Neo4j is transactional. It's awesome. It's ACID compliant. So don't forget about that. I don't know if is Mongo transactional. Doesn't matter.
Doesn't matter.
Yeah, does it? So So you don't want to lose data, so you have to do transactions. And so the first thing I'm doing is that I have, I want these nodes in the database to be unique. So I don't want to create 2 beers on accident that are actually the same ones. So you achieve this by creating constraints on node or on labels. So nodes have labels, relationship have labels. These labels are sort of the type of node that they are. So you have user nodes, beer nodes, brewery nodes, and then another way to that an idea I stole from Rick is to model the database in a way that the alcohol percentage and the IBU of the beer aren't properties of the beer, but instead they're nodes that exist in the graph. So if it's a 5% beer, you have a node called 5%. And all the beers that have 5% alcohol have a relationship from themselves to that 5% beer node. So if you want to find all the beers with 5% alcohol, instead of searching through all of the nodes and filtering them based on the property of alcohol percentage, you just go to the node 5% and see what beers have an incoming relationship to that one. So that's not that could be a bit of a performance improvement, but it also lets you model the database in a nicer way to query it, to do some cooler queries. And so that's one example of how you might model things differently in a graph database than you might not sort of recognize doing it instead in a relational database. You can pull apart the data about nodes that are common to them and make that a relationship. Right, so you could create these constraints on properties of nodes of a certain type. So say I want beer, I don't want beers to have, I don't want duplicate beers, so I created constraints on this property called brewery_db ID, because the database, the API brewery_db that I got all this from, they have their own IDs. And so I'm creating a unique constraint on that, so that way, if I try to put a beer in here that has the same ID as another one that I've already put in the database, then I will get sort of an exception in the transaction, and it'll say that something you tried to write something that was already there, so you have to figure something else out. But you also can do you can also do better guarantees about finding the nodes in a database by looking up on whatever constraint you made the constraint on. So I'm going to want to find beers by the brewery_db ID, and by having this constraint on it, it'll be a lot easier to find it, and I'll know that I only ever get one. So again, to continue showing how I imported the data. So I'll just explain how this works. So I get this is using the brewery API to get the data back from the server with the raw beer data. And so I get a iterator here over all those beers. So for each beer, I'm going to sort of parse the information I want and create a Cypher statement, and then filter it on and check what data I got back from the server and add on to that Cypher statement. And then when I get to the end, I'll commit the transaction creating that node and that beer, and then again do it for all the beers. So I know a few things about beers, so that they all have an ID. So I start a create statements. I have a beer with the variable b. So now I'm going to set some properties. So I set brewery_db ID, and I'll pass in a parameter map at the end. So just a hash map here of strings and objects. Names, whether it's an organic beer, what the description of the beer is, whether the beer has icons or not. Yeah, and then I'll put that information, I'll put these parameters in this little map that I'm keeping up to date. So when you execute the Cypher statements, you pass in this with these parameters, and then also this map of values for those parameters. So it's a bit easier to sort of fill in the information as you get it. And so, yeah, like I said, you do this for all these parts. If the beer has a ABV value, I'll add a merge statement to that. I'll add a merge statement to this statement. So I want to find the node of type ABV that is the ABV that this beer has. So I'll get that value. And what merge will do is it will try to match the pattern that it's merging on. And if it finds a node with that property, with the constraint is on, because I believe you have to have a uniqueness constraints to do merge. No? Well, it really helps to. It makes sense to do it that way. So you can kind of this is really easy to understand, that I want to find the node with ABV 5, but maybe the first time I do this import, that I go to this line, the first time I see ABV 5, it won't be in the database. So the merge will create that node with that property, and then I'll get it back as ABV, and then I will take my beer and create a relationship called has ABV directed to that node ABV, which will be created after this line runs. So I do that for all the different things. So there's also a one called original gravity, which I actually don't know what that even means, but it's something about beer.
It's the alcohol value before it ferments.
Yeah. And beers also have styles. So styles are modeled the same way. They're, Indian Pale Ale is a style, and beers that are that style have a relationship to it. So yeah, so this is basically the import, creating the beer and merging on all these different node types that it might have. And then
When you do that introduction, will you be smart enough to understand directly what you need, or do you change that script and add different?
yeah, this is just my naive approach of doing this import. So you can do it. The number of ways you can import the data is as many ways as there are that you could do it. I mean, there's many ways to do it as there are use cases. So yeah, the takeaway is sort of the creating these Cypher statements based on the data you get. This is just one way to do it. So right after, where am I? Right, and beers also they're also produced by breweries. So you want to add a label, add a node for the brewery, which may or not be created already, and relationship to that brewery. Right. So after you create this monster Cypher statements all committed to the database, and as long as executing this statement didn't throw an exception, I'll commit that transaction by marking it as a success. And if you execute this statement and maybe the merge statements didn't work, so something already existed and you try to merge on it, or you tried to create something that already existed and there was a constraint against it, you get an exception, and then you could handle it in a catch block and do whatever happened and try again your transaction. Yeah, so this is how I imported it. Fun fact, I was here last night trying to do this imports, and it took 40 minutes, and I had to do it 3 times because I kept messing something up. Right. So the pizza should be here soon, but I'll just keep going. I'm trying to get back to this. Here we go. Right. So users. So we're gonna also, we want to have some users in the database to actually do some recommendations with. So some interesting things that I just thought of that could be cool to have is users with names, job location, people that they follow. So you follow someone else, and then people can follow you, and you like breweries and like beers. So, of course, with all social networks, you have this problem of how do you do social networky things without people in your social network. So you just do like the best of them, and you just make it up. So I faked a lot of data to make a nice use case model. And so I did this with the Python driver, which I can't find that program. Right. Right, so Python. Python is another great way to use Neo4j. We're making a new driver in-house, but there's also a driver called Python Neo that I use that's also sort of made in-house. So I would recommend for now, check out either one of those. Right, and so I basically did the same thing here, so I won't show all of it, but basically you can create these user data nodes and relationships in the same way. You sort of get I get an iterator over all these people. I do merge, so you create again constraints on the different nodes you want. So you have users, they might have a job, and the job will be a node extracted from their data set. So everyone with that job will all have a relationship to that node. And again, so you merge on those and create your relationships and then commit them. All right, so if you've never used Neo4j before, you should know that the database comes packaged with the browser with the sort of browser session to use to query and look at the results, your query results in a graph way. I think you use D3 to build this front end. But this is one of the most awesome things about Neo4j is this way to sort of query the database while you're trying to build your queries and develop things and see exactly how it gets evaluated and what you're going to get back. So yeah, so when you start the server, it starts a web server as well, and so this is what we're looking at here. Right, so we can see some basic information about the database after I loaded everything in. You can see it's got about 60,000 nodes, the 17,000 properties, etc. This database is 200 megs. Yeah, and here on the left, I don't know if you can read it all, but this tells us all the different labels of nodes that are loaded in the database right now. So we have ABV, beers, breweries. This is all the relationship type labels that are in the database. And these are all the property keys of the different nodes in there. So if you just click on any of these, it'll do a simple query. That information. So this is just find all beer nodes and return them, and only return 25 of them. So if you look at that like so, you can expand the results, and this is the result of that query in graph form. Can I? Right. So this is one beer. As a description, you see all the different properties here at the bottom. And if you do a double click on that node, it'll load all the one step out things about that node. So this node has style American style brown ale. It's 8.5% beer. It has an IBU of 30. These two other beers that we already had found in the first query also have that same IBU, so they already got the relationship there. Yeah, it's made by this brewery. And we have users in the database, they've liked the beer, so we also get people who like that beer. And we see that, yeah, you can see the entire graph about it. So, and I didn't even do anything, so I just double clicked on that, and then you can see sort of what's going on. So when I was building this sort of website, it was really easy to sort of do this kind of thing and see, okay, did my data import come out the way I wanted? Did I have the right nodes in the graph? Things like that. And you can do the same thing for any other node type. So you can see all the alcohol percentages and see all the beers that have that percent. The browser is awesome, but it's also not super awesome when you have huge result set sizes. So a bunch of nodes will probably pop up here in a second. So I double clicked on that, yeah. And you get a little warning like it only showed 100 of them out of 1,000. Yeah, because it's just some JavaScript thing. So, right. So some example queries that I have smartly done over here. So say you want to find beers from a given brewery. Let's just put this in the browser and I'll explain it. So we are doing our Cypher query as such. So we start off with.
In what you did before, could you then go on and say, I only want to see this relation, by clicking there, and then get it filtered that way?
Oh yeah, and to just look at things with a certain relationship type. You mean?
Yeah.
Yeah, you could also
So
just
you had your 1,000
this.
or 100 or whatever it was.
Sorry.
In the graph mode,
Yeah.
could then go on and click on relationship type, you get only those that have that type.
Right. So, I mean, you mean something like finding things that only have this relationship. You click on that and you get it, or things that only have follows relationship. You get things with just follows and the nodes that touch them.
The new version has better options, I think, for creating and manipulating the graph. The new version that's not out yet, the 3.0 browser, will have more ability to edit and manipulate the graph in the browser. Right now it's mostly look at it, drag things around, it bounces and it looks awesome. But we've added a bunch of features for 3.0 and it's going to be better.
But you have to drill down.
Yeah.
You can, most of the stuff you hover over, if you double click on it, it'll drill down and give you, and let you focus on that particular thing.
Yeah. So yeah, if the browser leaves something to be wanted for, it's because we're a database company and we're just getting around to more, sort of putting more people onto this kind of stuff, because this is sort of a whole separate problem. But yeah, so that's query. So yeah, so say I want to find beer by brewery. This is a really simple query. You bind a beer type node to a variable called beer, and you say you want it to be produced by a brewery with this variable, and you specify that, oh, I want the one that has the name parameter is equal to this string. And this is a really awesome beer brewery in Holland. And if you run that, you get back all the beers that that brewery makes. So if I double click that, yeah, you see that that brewery makes all those beers. You can do more interesting things, like you said, find all beer with a certain alcohol percentage. So this is literally the exact same type of query you're modeling, where you're specifying one node's property to be 3.5. And these are just, and there could be a lot of these, so I just limit it to 5 to get a sort of thing. Same thing with IBU. So say you don't want a specific one, but you want something like a range, so anything greater than 100. Or it could be sort of between two values, but so this is just anything bigger than something else. That works just as well like that. So these beers all have a super high IBU.
Also known as average in the Pacific Northwest.
Yeah. So average IBU is like 50.
Lower, but yeah.
Lower. So these are, yeah.
Those will make your face pucker.
Yeah. And they happen to all be 150 IBU.
That's almost not chemically possible.
Yeah.
By clicking, you get the script, right? The click generates the script for you.
No,
The script and manipulate that again.
No, the script is just for me doing the presentation. So I just wrote these queries beforehand, so I don't have to type them up now. So this is just some text file.
Back to the graphical node, if you click on something here.
Right. So that's the browser. The browser is trying to be smart and helpful and say, give me all nodes that are sort of one hop from whatever you double clicked on. So it's doing a query in the background and then filling it into the view. So if you double click on that, it's kind of like doing a
Go to code.
Huh?
On the left side, go to code.
Yeah, this is about
That's
the
not the right thing. Okay.
so yeah, so the browser is using the HTTP
Right.
driver to talk to. Yeah.
Well, it will change now, of course.
Right.
Yeah.
Because the browser is, when you double click it, the browser making a request, but it's not a Cypher request. So that's why you don't see that Cypher is making a low level request, but when new drivers coming out, they make Cypher requests. So when you go to the code, you'll actually see the request that it made, and that's what yours.
Right. Because right. Okay. Yeah. So,
So you
this
get
is using the HTTP API. In the next version that comes out next month, the way the browser talks to the database changes, and it actually sends Cypher to the database. So yeah, that makes sense.
Yeah, so it's kind of doing a query like that in the background. I don't know if that helps. I don't even think. Yeah. So these are all sort of basic queries to get things out of your database. We get some more interesting ones like breweries with an IBU of a certain value. So I'll show that one. So say you have a brewery, it produces a beer, and the beer has an IBU value, and you want to only return these patterns, where within this pattern the IBU parameter for this node has a value over 80. We want to return them according to this is returning which breweries have the most beers with the value of the beer being higher than 80. So if a brewery that has a lot of beers that are really in the high value, those should be returned first in this kind of query. And so we see that's how we get. So Stone Brewing Company apparently makes 29 beers with a super high IBU, followed by all these other guys. So that's kind of a recommending query if you want to find only strong beers by this one company. And you can do the same thing for brewery making 2% beers. But say you want to do something else interesting, like finding recommendations about users. So there's a switch. Users like the same breweries I do. So say you want to recommend friends to someone, there's a lot of ways you can do that. Which was a difficult thing to think about in making a sort of website. Okay, you want to recommend things. A graph database helps, but it only helps if you know good queries and ways to formulate a metric to say, well, this is a good recommendation because of this reason. And I probably haven't found good recommendation metrics, but these are just a couple of things I tried. So say you want to recommend people based on similar likes in a brewery. So just pulled out some fake username. So I'm going to bind to that and start my search from there. And that's me. And so I like a brewery and I want to find some person or some people who also like that brewery. And so I'm going to be returning that and finding the people who have the most likes in common with me. And so we see that it is not, so this person doesn't have a lot of friends, I guess, who have a lot of overlapping likes. But yeah, that's how you do that. I mean, that's pretty simple.
Does you mean you present an aggregate function that you are grouping the database and then you got a certain data from it, including count?
Yeah, so this is getting the results back and then aggregating them, I guess, and finding and ordering them by those counts the times that occurred. And that way by the ordering, all the first results will be the ones with the most occurrence. This is a different path. So this is me, finding. This is a query I follow. I want to find people who I follow and beers that they like. So my beers that my friends like. but beers that I don't already like, and give me those beers in the order of the most likes that they have from my friends. So if all my friends like beer A, and most of them like beer B, then give me all these beers back, and but of course in the order that they're liked most. Yeah, and again, this is really simple to model, and I think it's pretty clear. So if we model that, you can see, okay, well, oh, cool, these two beers apparently are really popular. And yeah, indeed, they're followed by all my friends. Yeah, so I can keep going through some of these other queries that I invented. I don't know if any of you guys want to try to work on, like, have any questions about them or, yeah.
In your database, it's based on pointers. Like let's say the user like several beers, so you have several pointers to several nodes. So in case like you have an inquiry, what Jack likes, you basically have a pretty fast inquiry because you go to the value directly.
Yeah.
But let's say that we have an inquiry in an opposite way, what Jack doesn't like. So we don't have a relationship in this case. How can we list the beer?
So you want to find all the beers that Jack has not liked.
Yeah.
Right. So, yeah, that's. Yeah, but this is simple. Like, what beers don't I like? So it's basically everything besides things that you like. So you basically return the whole database filtering out things that you do like.
Except the one that I have a relationship with.
Right.
But how would look like the equity in this case, and performance-wise?
How would the query? Well, the performance I don't think would be very nice.
Performance of that would be based on the size of the number of beers.
Yeah, because you.
If you have a lot of beers, more results, performance.
Right. So it would. So if I get you right, you would say you want Right. So basically, you want this query.
No, just say comma instead of like. Take away the relationship and put a comma there.
Yeah.
And find me and find all beers.
That I don't like, or this relationship's not there. Yeah. And the nice thing in the browser now, it's giving me a warning, and it says this is going to be a really slow query, the way you've written it.
It says Cartesian product, but it won't be because there's only one user.
Okay.
And the warning is for the comma. That first line says find all users and find all beers and find all combinations of user and beer. So if there's 10 users and 10 beers, that's 100 results. But it's only one user, so it's not really a Cartesian product. If you put a unique constraint on there, then it will know enough to not give you the whole.
Yeah, when you're doing this, you can prepend profile and explain, which are different. How?
Explain won't give you the DB hits.
Okay.
The red stuff, all the DB hits and arguments. Profile gives you this query plan plus all of those numbers there. It tells you how many rows were produced by each part of the plan. If you do explain, it won't actually run it. You will just get this graph without those numbers.
Okay. Yeah, so you can see.
Little arrows there, you can expand and get more detail on each of these.
Actually, if you run explain, it's very similar.
Yeah.
Yeah, it just doesn't tell you what comes out of the database.
It'll take away the red parts and the numbers.
Okay, so I won't actually evaluate the query. Okay.
Right.
I'll just use the query planning and then.
But it's got estimates.
Yeah.
Very nice.
It uses the estimates to decide what's the best plan to solve it. Because there's maybe 20 different ways of solving a query, and it will take all those estimates based on statistics to work out which is best. It makes a big difference for some queries.
Uh,
It does this as well.
What does it is only change the where to not or equal. But here you have to change the whole statement just because the logic is different, of course. And performance-wise depends on the next.
So what do you mean you have to change the whole statement?
Yeah, because
So-
in SQL just have to see if it's, we like it or not. I cannot now measure it how,
Mm.
but it will be something in the where or equal or not.
But I think
or
what you're
not
saying
even.
is take away that not. See the not over there? If you take that away, then you get the positive one.
Oh,
yeah,
so this
yeah,
is
but yeah, but yeah, okay. But when you put it as a relation, it will be performed faster. If you said like where Jack like.
Yeah, but that's a totally different query. Then you're asking about friends and what they like. That's not what
yeah.
you're
So
asking.
this
I mean
particular
that one
query.
exactly. But if you just make it match user like this one, it will be faster than asking 2 and then percent.
Yeah.
Because
Yeah.
this is why the relationship is good to make it faster.
Mm.
Oh. Oh.
And
Yeah.
That's much more efficient, you're right.
Yeah. Interesting.
It's the Cartesian product that stumps.
Yeah.
Because it can't rewrite it to that form when it's a Cartesian product.
Right. So I think I will just show one more query that I was working on right before this started. Let me. So maybe it works. So let's look at it. So I want to find a range of values, or I want to recommend the range thing. So I start with me, and I like a certain beer with an alcohol percentage. I want to find from all the beers that I like, get the average alcohol percentage, store that as a variable. And then I want to do a second query. So I want to find some people who like a beer that, so find people who like beers. And from those beers, when their alcohol percentage, filter on things that are in a range between the average beer value that I apparently seem to like. So if I like 5% beer, and this is probably too big of a range.
Yep.
But if I like a certain percentage of alcohol, maybe I want to find beers that people like that are between, plus or minus 1 or 2%. And I want to find the popular beers. So if I like 5%, I want to find all the popular 4, 5, and 6% beers that everyone's drinking. But I don't want to see all the popular beers that are like 10% or something. So that's kind of a nice recommendation. So that was sort of the most advanced idea that I had.
that query works a lot better if you're doing IBU instead of ABV.
Yes. So if I sort of switch this to IBU. Okay. How does that work? Nice. So this is recommending these beers because they apparently are really popular among people with my users' preferred IBU value. Yeah, and also interesting, actually one last thing then, to look at what this user looks like. So this is one user in my database. He has the guy really likes a lot of beer. So this actually doesn't work that well when he has so many likes of beers. But you could see all the things about the person. So if you wrap all this up into a nice Python web app that we threw together today, you basically take these queries and put it into your model. So if we use Python Flask, which is a really popular Python web framework, MVC, and when you do these queries, you have your user that you're logged in as. And you basically do these same queries I just went through, and passing in, with the user that's currently logged in, evaluate the query as them, get back the results and return them. Right.
And you have amazing graphic design skills.
And graphic design skills?
Yeah.
Yeah. Yeah, you can. Yeah, I'm not really sure what's interesting to see here, so I guess I can just go to the awesome webpage. So this is our famous Swedish person, Judith Lindahl. I don't know. Yeah, you can see different styles of beer in the database. So we're just doing a query get all style nodes and fill them in here. Find all breweries, which is a slower query for some reason, and get all the breweries and list them here. We can then make a page for it where we have the brewery information queried and then populated into the website. They make, yeah, this is for this brewery, this is the beers they make. So actually doing a query where we pass in the brewery ID, doing a query for all the beers that produced by that brewery. And we're selling them here, so they just make one.
And it's obvious what it does because it's beautifully designed.
Yeah. So here's one of the best breweries in the world to make Bud Light. And then we can, yeah. So this is all just doing queries in the background. Yeah.
It's the same as urine.
Yeah, and so you can also find your friends. This is doing a friends query, and then querying the nodes that are about their location and their job. So we threw this all together in the afternoon, so it's nothing special, but building this in Python and with Neo4j as the backend, doing the queries is really easy. So, like I said, this is basically all you're doing is finding all breweries. Okay, there we go. Get all the beers by that brewery.
This is the least efficient way possible to do it.
Yeah, there might be more efficient queries and some caching you can do. I don't know. Yeah, and then the interesting one, recommendations. So, this is nothing to be proud of, this website, but yeah. So we apparently me and these people like the same breweries. We like the same beers with these people, and we can easily see, okay, how many beers in common we have. Why do we like the same beers? You can usually see from the beers that you like, give me the breweries that produce this beer in the order that they have produced the most beers you like. So if I really like all these beers and they all come from one brewery, we want to know that. Same thing with the friends. So this is sort of a friend of a brewery query. Get back all the beers my friends like. That's nice.
A lot of those are tasty beer.
Yeah, a lot of these are tasty beer because they don't have a description. Yeah, if me and my friends like the same brewery, then... Oh, so these are friends of mine who we both like the same brewery as well, but we're also friends, and they like these beers. Yeah. So, that's...
Your local host
Yeah.
available on the internet so that I can try it then?
It's not right now. I could put it on the internet. Can we email everyone that came tonight with links to information?
If you signed up, we can send you an email. So if you signed up on Foo Café for this event, then we can send you an email.
Yeah.
Will you also send the data which you use, the 56,000?
Oh, that's
CSV
I
file or something?
no. So I pulled it directly from the API web service that I got it from, and I'm not certain that I can share it because I had to pay $6 a month to get access to the API. So
I think that's against the rules.
that's against the rules. So if you give me $3, then get a no. No. So yeah. we can talk, I guess.
Yeah.
I'll send you. The code for getting all this. Anyone can look at it. So there's no more other questions. I hope you have seen that building a web app with Neo4j is really nothing to sort of be afraid of. It's not any more harder than building it with any other database. And then once you get going, these really cool queries are pretty easy to model in the database, and then you can quickly build a website that has really interesting and relevant data shown to users. And also I built this website starting off from a template that another person at Neo made. So it was a blogging app thing. So if you want to try something else, just search on GitHub for Neo4j Flask, and you'll find at least one good project to sort of start off with. Yeah. So cool. Thanks, guys.